Alright guys, this is going to be the last video in the series, I think. I think this is where it stops at, but I think this is a prime time to actually show you where differentials could go. Alright, let's jump right into it. So use a differential to approximate the rationally. Rationally means give me a fraction as an answer to give me an approximation. So this is how we're going to do this. It's really commonsensical. Okay? If I looked at the cube root of 3, this is what I know. The cube root of 25, this is what I know. I don't know anything about it. But if I wanted to approximate it, that's the goal. That's the goal. We'll do two examples, I think, and it'll make much sense. Let's do it in yellow. So this is kind of like saying, well, let f of x equal the cube root function, right? And then we input 26 in, right? Like that's really what's happening. So really what this is over here is this is f of 26. And that's the way we want to look at it. And why is that? Because if we look at it like that, then we can say, well, 26 is really 27, right, minus 1. And that's true. Now, why is this helpful? Because I know what the cube root of 27 is. So approximating that would be so much easier if I wrote it that way. So check this out. If I know that I'm looking for f of 26, correct? Well, using what I know from the last video about the differentials, and what does the differentials mean? Yes. It means that f of x plus the change in x, right, should be approximately the derivative at any point times the change in x plus the starting point of f. Okay, this is the very last thing we talked about. So look at the last video if it is unclear. Okay, so I'm going to show you how this works, okay? This answer needs to be 26. But because I'm using the cubing function, I want the input to be something cleaner. So I'm going to say, let's call x 27, and this is the change in x then is now minus 1. Okay, that's where I went. So that means that this will be f. So that means that effectively what we're going to have here is f of 27 plus negative 1, which is 26, by the way. This thing will be approximately the same as, okay, f prime of 27 f prime of 27 times the change in x, which is minus 1, plus f of 27. And what this means is now I can use, and I want you to take a look at what I have here. This is pretty outstanding, to be honest, is that I can figure out what f of 27 is. I can figure out what f prime of 27 is because I have a function. What I can't figure out is what f of 26 is. So what I'm using is a differential to help me approximate what f of 26 is. And f of 26, we've already talked about, is just a cube root of 26. Okay, so the cube root of 26, I'm going to write it as f of that when the function is defined as this. And then we just plug in the values accordingly. So it's all about making this connection in red. That's super huge. All right, let's see if we can grind through this. So f prime of x should end up being 1/3 x to the negative 2/3. And if you plug in 27, what does that end up giving us? I have no idea. I get 3 cubed 1/9, I get 1/27. So this is approximately 1/27 times negative 1. Is that right? Cube root is 3, squared is 9, 1 over, yep. Plus f of 27, which is just 3. And that means when you run this all through, I get 80 over 27. So therefore, and this is the big deal, you could look forward to having a problem like this in the future. Square root of cube root of 26 is approximately 80 over 27. Right? We needed an answer as a rational. Okay? Very, very simple. Let's take a look and let's do it again. Okay? All you need to know is that sometimes you could use a differential to do it. So here we go. Square root of 7 is like saying, let's let x equal, let's let the function f of x equal the square root function, right? And then that means figuring out square root of 7, we'll really just be doing f of 7. Well, I want to choose a perfect square root that's close to 7. In this case, I'm going to choose 9. That allows me to rewrite this as f of 9 minus 2, or plus a negative 2. Now, what is the whole point of this? Again, is to leverage what we know about differentials. So this would be x, this would be the change in x, and then all you need to know is the formula and where it approximates to. So this is going to be approximately f prime of our x, which is 9, times the change in x, which is negative 2, plus f of 9. And this is huge, because if after I grind through all this, that will be my approximation of square root of 27, and I didn't even need a calculator. That's the crazy part. So this would be approximately, well, square root, we're going to need a derivative, so f prime of x is 1 over 2 square roots of x. So that ends up giving me 1/6 times negative 2 plus f of 9, which is 3. So that's approximately negative 1/3 plus 3, which is approximately 8/3. So square root of 7 is approximately 8 over 3. This is exactly how you guys would show your work. It's really, really that simple. All right, guys. This is it. It's the end of the course. Last 6 minutes of the video. I just want to say it was a pleasure. And always keep thinking. Calc 2 is just one step away. I'd encourage all of you guys to take it because this is just the beginning of it all. All right, guys. See you on the next video.